So this PowerPoint is on Chapter 3, Sections 3 and 4, which are going to look at and compare the metal elements to the non-metal elements. So the physical and chemical properties of metals, and there will be a couple questions where you are going to need to know several of each of those for metals and non-metals. The physical properties of metals are they're hard, they're shiny, they're malleable, meaning you can pound them into shapes. They're ductile, they can be pulled into a long wire. They're conductors of heat and electricity, and 3 of them are magnetic: iron, cobalt, and nickel. Chemical properties look at the reactivity. 2 columns or 2 groups are very reactive, the group 1 and group 2 metals. Most of them are very unreactive or non-reactive. Some metals, when they react, when they're exposed to air or water because of the oxygen, will start to wear away, which we call rust. So iron and oxygen, when iron is exposed to oxygen, creates a compound called iron oxide, which is known as rust. There's a key definition called an alloy, and it's a mixture of 2 or more metals combining the best properties of each. There are 3 examples from your book. Copper and tin combine to make bronze, copper and zinc combine to make brass, and then iron, carbon, chromium, and vanadium combine to create stainless steel. It's the amount of iron compared to the carbon and chromium that determines the strength of the steel. Your group 1 elements are known as the alkali metals. You want to know this group by name and number. These are the most reactive metals. They are only found in nature in compounds, never as individual elements. These elements are soft and shiny. You literally can cut them with a plastic knife. The 2 most important are sodium and potassium because they are used in our bodies in lots of different ways. The alkaline earth metals are the group 2 metals. They're not as reactive as group 1, but still more reactive than most other metals. They too are found in nature only as compounds, never as individual elements. They're hard, a bright white, and they're good conductors of electricity. The 2 most common are magnesium and calcium. The transition metals are a large group. It's groups 3 through 12, and they form a bridge between the reactive metals from groups 1 and 2 and the not as reactive metals of groups 13 through 16. Most of these metals you see every day. The common ones are iron, copper, nickel, silver, and gold. All transition metals are good conductors of electricity. They're fairly stable. They don't react very quickly or not at all with air and water. The mixed metals are groups 13 through 16, and they're called the mixed group because within the group you have metals, nonmetals, and metalloids. Metals in this group are tin, aluminum, and lead. The lanthanides and actinides we don't worry about too much. They are the rare earth elements. They typically would fit between groups 2 and 3 in periods 6 and 7. They're soft, shiny, malleable, and have high conductivity. Only 2 of the elements exist in any significant amount, and anything after uranium is lab created. The nonmetals for section 4 know these properties as well. So they're kind of the opposite of anything you would have with a metal. The physical properties are either a gas or solid at room temperature. They have low boiling points. They're dull, brittle. They have low density, and they are not good conductors of heat and electricity, so they are known as insulators. Their chemical properties is they readily form compounds, except for group 18. Those are all nonmetals, and they are all noble gases. Whenever a nonmetal combines with a metal, the nonmetal is going to gain electrons from metals. If they're combining with other nonmetals, they share the electrons. And this is a key definition to know. A diatomic molecule is 2 atoms of the same element sharing electrons. So O2, H2, N2, those are all 2 atoms of those elements combining to create those gases. O2 is oxygen. Now, there's some families of the nonmetals. The group 14 is known as the carbon family, just because carbon's the first one in the group. Group 15 is the nitrogen family. Don't worry too much about those. The key one to know is group 17, the halogen family. These are the very reactive nonmetals. Fluorine, chlorine, bromine, and iodine are all used in some sort of cleaning. Noble gases are group 18, and these are non-reactive. They don't form compounds with other elements. And then hydrogen is above the group 1 metals. It is not part of the alkali metals. But know that it makes up 90% of the atoms in the universe, but only 10% of the mass. The metalloids are on the zigzag border between the metals and nonmetals. They have characteristics of metals and nonmetals that are based on temperature, light, and how pure the substance is when it's working. Their most useful property is their varying ability to conduct electricity. Metalloids, also known as semiconductors, conduct electricity or they insulate based on temperature. It's the semiconductors like silicon, germanium, and boron that are used in most of our computers. When they get too hot, they slow down and act as insulators. When they're cool, they act as metals and allow the electrons to move, which we call electricity. Okay, section 3 answers. First question wanted to know what the 4 main properties of metals are, and they're shiny, they're ductile, they're malleable, and they're good conductors of heat and electricity. Metals are found on the left side of the periodic table, and they react more easily than the metals further on the right. 80% of the elements on the periodic table are metals. And then element 119, if it was found, you would have to figure out where it would be, and it would have 1 valence electron, so it would create the 8th period, and it would be highly reactive. Okay, section 4. The nonmetals are located to the right of the zigzag line. Metalloids form the border between metals and nonmetals and have characteristics of each group. Remember that metalloids are also known as semiconductors. Properties of nonmetals are that they're a gas at room temperature, they're dull, brittle, they have lower density than metals, and they are insulators. Noble gases seldom form compounds because they do not gain, lose, or share electrons. Metalloids, again known as semiconductors, have characteristics of both metals and nonmetals. And then they had this question, where is iodine and what would it be like? And it's group 17, period 5, so it's in the halogen family. Xenon is group 18 right after iodine. It's a noble gas. And then selenium is group 16, period 4.